tutorial, using Tyflow, I'm going to show you how to take a complex set of objects all animating together to create an animated flower that grows with a curling prehensile stem and unfolds at the top with a flower bud with many animated petals. As you can see here, this is what's happening. We have the flowers all growing up and opening up, and all that animation is driven, both the scale of the flower and the animation time of each instance of the flower is all driven by the same bitmap. So once you've created a cached animated flower object, you can use a bitmap in Tyflow to control both the scale and the playback time of that embedded animation. So let's get started. So here we have our flower in all its different parts. Right now I have the stem, which is animated by the a bone structure here. So that's what's creating the animation of the flower. As you can see, there's many different parts. I also have this one opening leaf here, which is also created initially by a single mesh object with a bone structure, which you can see right here. And that's right there. So I have a bone structure, and it's creating the animation on a piece of mesh that becomes the leaf, and then I am using point cache to capture the animation of that one leaf there. As you can see here now, here's the point cache applied to that leaf, and so I am then copying this object here many times and putting it into the bud of the flower, which then, so I have many copies of that leaf animation, and they're all offset in different timings so that they all don't open at the same time, but they kind of unfold more naturally like that. So these are all sharing the same point cache animation, and in order to make this demo work, you're going to need to see this point cache animation somewhere on your hard drive. So instead of loading each point cache for each of these flower petals, you're going to want to go to your asset, go to reference file, reference asset tracking toggle, and open this up, and you're going to find our point cache file, which is the leaf skin unfold _ snap.xml, and you're going to find this in the folder or the zip file that I sent the demo out with. So go ahead and just find this and set the path by saying set path. Find out where this is on your hard drive, with the unzipped package that we sent with the demo, and then just set the path there, and that should show up right there. All of your leaves that are animated here should then find their point cache file system. Or if you can't find it, you can always just make a new one by opening up this original leaf and make a new one and send it out, and then, well, it'll be complicated because then you have to copy it around and do all that work. So anyway, use the asset tracker. That's the best way. Okay, let's get back to business here. Now that we have this flower, and you can see the flower is made up of different objects. We have this is the master object, and that's linked to the top of the bone chain that is the skin object bone set. So what we want to do is take this, all these petals here, and we want to also take the stem, and we want to join those into one single object, which is going to have this animation embedded into that one single object. And we're going to turn that one single object into a reference node that we're going to use in Tyflow to scatter around a surface. So how do we do that? Well, we're going to use Tyflow because Tyflow is all powerful. So let's go ahead and create a Tyflow right here, and you're going to create probably one of the simplest flows you've ever created with just one operator. And let's go ahead and do that right now. we're going to go ahead and just create, where is this? Export particles. And this animation goes from there and it ends right around, let's say it ends at 256. And I actually made it that length because in 8 bits there are 256, and since we're going to be driving everything with the grayscale bitmap, that number is going to become important later on. So let's just go ahead and make this 256. And what we're going to do is go down to Geometry Settings. We're going to click the button that says Include Additional Geo. Now we're going to select all the objects that we have without we don't need that dummy, and we don't need the bones. We just need the geometry. And we're going to add selected. And now we have all these guys in the list. As you can see, there they all are. We have our 21, 25 petals, 27. There's lots of them. Lots of flower petals. Now we're going to go find a place to put this. So let's go ahead and go to Ty Cache Settings, Output. Click this button. Click Browse, and we're going to go find a place on our hard drive. So I have this in my project folder here. Just all my caches are going to be kept in the same place. Ty Cache, and I'm going to hit make a new folder. Just call it B and save it. And let's go ahead and generate the cache. All default settings except for what I just did here. There, now that's done, and it should create the cache object automatically. Let's go ahead. Oh, one more thing. So we have this. We're all done with that. Now we can put this away. I also created, and this is really important, when you're creating an object that you're going to use this method, or a set of objects, make sure that you generate and give everybody the same material, multi-sub object material, so that we can take all these different objects with all their different materials. All these objects have the correct material ID number to work with this multi-sub material, and we're going to assign this to your cache object as well. So let me go ahead and hide all of our objects here that we used. Let's go ahead and hide selected, and here we just have the cache object. Let me hide that too. Let me hide all those bones with a big filter right there. So now we have this object here, and we can see this is the cache, the Ty Cache object playing back. All those objects are joined into one, just like that. So we can just scrub back and forth, and you can see this is one single object. And now we can assign our multi-sub material that we used in the creation of these objects. We're going to assign that there, and look at that, everything works out. All the material IDs are in there, and as you can see also it disappears when we run out of cache time, but that's not important right now. So now we have a cache object that is animated, and we're going to use this cache object as a reference node. So let's go ahead and select this plain object here. That's where we're going to scatter our Tyflow objects. Let's close that, and let's make up here in the Tyflow editor, we're going to hit the new button and make a new flow. With this plane selected, I'll right click here, and we're going to do simple scatter flow. Scatter on the selected objects, yes. And there we have, let's see if we can see a little better with this, like that. And so this is where all the flowers will appear just kind of randomly. Let's go ahead and add a little bit of separation so that, something like that. And then we're going to go to Shape. And let's turn off the scale. And we're going to pick Reference Node and pick the cache object. And there it is. And let's go ahead and hide the cache object now. And while they're not rotated correctly, let's go ahead and just alter that. Now they're all standing up straight. And then we can also, let's give everybody a random divergence on rotation and restrict divergence to axis. And we're going to give it make sure it does it along the Z. And as you can see, we're all starting out We're all starting out, everyone is not animated. So as I scrub back and forth, you can see that it's not playing that animation back yet. And how can we fix that? Well, where is our shape operator? Let's go here. And let's go down to animation, and we're just going to click animated geometry. And the end frame is 256. So now what happens? Everyone is animated. Look at that. Okay. And then when we get to the end, what's happening? It's looping. So we can turn off the loop like that, and it'll just hold. Like that. It'll hold that last frame. Now, what we want to do is two things. We want to drive the scale of each of these instances with a bitmap coming off of this plane. So let's go ahead and do that right now. So I'm going to grab a scale modifier, a scale operator, and we're going to drop this right in here. First things first, we're going to go up to timing and set this to continuous. And close that. We are going to do scale absolute. Turn that off there. And then we are going to go texture map, multiply by texture map, and we're going to pick this object. Oops, we're going to pick our scatter plane, add selected, and now it's in there, but we don't have a map yet. So let's go open up our material editor. And let's open up Slate. Let's make a new view. And the first thing I'm going to do is create a texture called the output. Where is output? There's output right there. And this I'm going to put, I'm going to use this node to throw into the scale because I want to be able to plug and change new textures going into this map node without having to keep reassigning this output. I don't want to keep reassigning new maps into this place here. I want to do it all within here. So this right here is the vector to get into our scale operator and also some other places that we're going to do too. So now we have that, and I'm going to move this over here. Move it off screen, and then we're going to create, let's try a gradient map. So I'll just do this one here and plug that in there, and then like right away, there it is. Look at that. So now we have, as you can see there, scale is being driven by a bitmap. So it's black over here and it's white over here and gray in the middle. Now, if I were to actually turn this on in the viewport to see that bitmap, it would really slow down our scrubbing here. So I'm just going to leave that off. But you can imagine this bitmap showing off there, and but we're going to keep that off just to make things go quicker. So now we've achieved that, but there is no. What we want to do is drive the animation of each of these instance nodes with this texture map as well, so that we would have the end of the animation showing up where the white pixels are and the beginning of the animation showing up where the black pixels are. As you can see right now, everything is linked. The animation playback of that instance node is actually linked to our master time, and we don't want to do that. So how are we going to do that? Let's bring up Tyflow. Here we have our editor, and so what we're going to use is something called a surface test. We're going to throw surface test right in here, and we're going to select, since we have the ground object here selected already, we're going to just go ahead and add that. Make sure our timing is set to continuous, and it is. And we're going to do, we can test all these different ways. Look at all those different tests we can do. We're going to use a texture test. So what it's going to do is it's going to sample the texture wherever that particle is. It's going to grab the texture map value at that point in space. And so we're going to go here and let's take the output of the output. We're going to throw that right in there. and instance that in. Okay, there we have that. And then we're going to go up to test action, and here what are we going to do? We're actually going to click this button that says data, save all test values, and we're going to create a custom float. Now, custom float is just a variable. It's the name that we put in here is arbitrary. I'm just going to call it bitmap. You could call it anything you want. You could call it Batman or anything, and that just becomes an arbitrary variable. So bitmap, and I'm going to copy that name so I can use it somewhere else. So now, when we get to this operator, it's going to say, where's this particle landing on that bitmap? And it's going to grab the grayscale value in a float value and put it into the custom float called bitmap that we can use in other operators within our flow. So let's go back to shape, and we're going to go down here to the reference node and to the animation section, and we're going to pull this down here, this menu, and we're going to do custom float full control. And here we have this channel show up right here that we're going to paste the word bitmap into there, and now it knows to look for a custom float named bitmap. If it finds one, it's going to grab that value and it's going to throw it into the animation control time that is going to control the animation time for that node. And here it is. Now it's working. So as I scrub back and forth, you can see that there's no change. Oh, here, let me move this up a little bit so we can scrub. As you can see, there's no change. Everything is staying the same, even though it's processing. I can hear my video card fan spinning, but nothing's happening because I'm not changing that bitmap. This gradient right here is not changing at all. So if we want these to now animate and move through time, we're going to need to actually change the bitmap values. And so there's many different ways we can do this. We could do an animated noise. So let's go here and make an animated noise, and we can see that work. So I'll go noise, and let's just move this and put it there. And now that should update quite easily in there. And then we're going to see now this is a noise. So instead of controlling this with a gradient, we're going to be sampling this noise value on that bitmap, on this plane, and moving those values into the animation time as well as the scale. So if I were to go in and create a key for, let's animate the phase. Let's go to phase or frame 30, go phase 1 there. And now we have all these little particles moving through their animation time, and also the scale based upon the texture map, which is the noise. And so if we wanted that to keep going, we could go in and go into our editor here. Let's pull this up and go to the slate view. Where's that noise? And there's the phase. And we can go in and how do we want to do this? Take these keys here, and we're going to make it a relative repeat. So now we have the phase speeding up, slowing down. So it's actually doing the ease in and ease out, but that kind of looks cool. So let's see that work. As I scrub through here, we can see all these flowers kind of doing that. That's really neat. Look at that. So that's one way we could animate. We'd have an animated bitmap doing that, but there's other ways too that you can use this texturing method to move. We could actually just move the mapping coordinates. So let's go ahead and put this. That should update that. So now, as you can see, there's that the gradient is not animating, but what we could do is put a UVW coordinate on here. So let's do a UVW mapping coordinate. And now, if I were to go in and move this gizmo, we'll see what's happening there. Moving the mapping coordinate around will actually do something. So that's kind of neat. And we can do mirroring and flipping and all kinds of stuff like that. So we can tile it and all and things like that. So this is a great way you can organize the timing of your particles and the scale in that way. And we can also animate if we wanted to animate over time this mapping coordinate, we'll set a key and we could scale it down. And when I do that, it's going to tile. So it's up to your own creativity to see what you're going to do with that. So here, who knows what can happen with that? So that's how you drive animation with a texture map. That's how you drive scale with a texture map and how you do them both together. So I hope you enjoyed this tutorial. Thanks.